In this video, we're going to talk about interfaces, and at first glance, as I begin to show you interfaces, you're going to say, man, that looks an awful lot like an abstract base class. And you're absolutely right. They share many things in common, and I think the best way to think about it at this point is that you'll come to learn that they serve two fundamentally different purposes in object-oriented programming, and I'll discuss that difference, that crucial difference, in just a couple of videos from now. But I want to talk about the mechanism of interfaces itself, and then we can talk about the purpose of abstract base classes versus interfaces. So once you understand the what and the how, then we'll talk about the why would you choose one over the other. All right. So, and I think that one of the key differences here is that whenever you need to work with two fundamentally different classes, but at some point you need to treat them the same way, then you might want to choose an interface. In this case, we have, as you can see on screen in Inheritance 16, pause the video, catch up, create this project, and add these two classes. You can see that I have an appointment that has like the name, who this appointment is for, and then the start and the end date for that appointment. So it might be an hour long, 2 hours long, whatever an appointment would be with a counselor, with a doctor, or whatever the case. And then you have a product, like a book, that has a title. And if you scroll up here, you can see that, how I'm using these two. What I want to do is enable my website, for example, to sell both of these at the same time in the same transaction. So in this case, I might say, okay, I want to schedule an appointment and purchase that book from that author. And so what you could do is create an instance of appointment and create an instance of book, but then how do you complete the transaction? You could create an abstract base class, but you know, these two don't really share much in common. I mean, one's a date, an appointment, and one is a book, and there's physical properties like shipping the book and so on. And so whenever you're faced with this, you can kind of extract out the thing that they have in common, the thing that you want to do with both of them, the action you want to take, and you can turn that into an interface. So in this particular case, what I'd like to do is create an interface called iPurchasable, and let me explain why I would name it something so odd. All right, so let's just start with an interface. And here I'm going to call this iPurchasable. All right. And then what do we need in order to complete a transaction? Well, they both have a price that we're going to need to, they both will have to have some price that we're going to charge for them. So that's a good place to start. So we'll just do, we'll do double price and then get set. Okay. And then we'll want to create a purchase method that will get called by some other method, like our main, that will actually call purchase on the appointment and the book and complete the transaction. In one case, would schedule an appointment, block off time on the individual's calendar, and in the other case would actually get shipping information, charge taxes, and things of that nature, right? All right, so now how do you inherit from an abstract base class, and how do you inherit from an interface? The same way. You basically will just use the colon character and then iPurchasable. Now notice when I do that, you'll see that there's a red squiggly line underneath iPurchasable. If I hover my mouse cursor under it, it says that it doesn't implement the interface. And so what you can do when you see that little yellow light bulb in Visual Studio 2017 is just hit Control period on the keyboard, and it kind of shows you what's going to happen. It's going to add a price property and a purchase method. So let's go ahead and hit enter on the keyboard, and it creates both of those for us. Now, it just gives us these stubbed out implementations. In our case, I don't need anything fancy for the getter and the setter. So what I'll just do is erase that and just do get set, and that should fix our price property. For the purchase, however, I'm just going to do something simple in this case, since it's just intended to be a simple example, and print out something to screen. So I may just want to, for the book, just print out the title and the price. So we'll just paste that in there like so, console.write line, and then I use the interpolation character for the string to print out the title and then the price, and I'm going to format it as currency. Okay. So I'm going to need to do the same thing for appointment here. iPurchasable, control period, implement the interface. We'll get rid of this get set and implement our own auto-implemented property. And then same thing with purchase. I'm going to go ahead and just paste in a console.write line that does something simple like just say, hey, the payment for the appointment for whoever it's for, and then the start and end time, and then the price. All right? So now what I need to do is actually use this, and I would expect to get into my complete transaction a list of things that implement iPurchasable, and I'll just call them items. And so here, at this point, all I need to do is just like, do a for each tab through items, and then call items item dot purchase, like so. Let me show you a cool one-line way to do this. So let me just comment this out, and this is really just a little tip. You don't really need to do it this way, but I try to keep things nice and compact and obvious. So we can use the for each method, which, as we can see, is a lambda, or I'm sorry, a link expression method. So for each, and then I'll get passed in individual items. So I'll be able to call purchase on each individual item. And so that's just a one-line representation of this for each statement. And it'll do the same thing, okay? So now that we've got our complete transaction set up, what I'll need to do is add the price for each of these in order to get this to work. So let's say that the price for the appointment is $100, double, or $100 in this case. And then, whoops, I guess I don't need that. And then here, price, we'll say for the book, is 50. All right? So far, so good. And then what we'll want to do is go var items equals new list of iPurchasable, and then we'll go items.add the appointment, items.add the book, and then we're going to call complete the transaction. And even though we're dealing with two fundamentally different types, they both implement iPurchasable, so we'll be able to add them both in the same transaction and have them go off and do whatever they need to do for fulfillment purposes. But at this point, we should be able to run the application and see that our purchase will be for a payment for an appointment for Bob at 9:05, ending at 10:05 for $100, and then purchasing the book, implementing how to implement interfaces for $50. Okay? So hopefully that makes sense. Let me talk about the naming convention that I used here. So it's just a naming convention. You'll see plenty times, especially in other programming languages, where they won't even add the I. The I is kind of a holdover from an old naming convention used years ago called Hungarian notation. But it's helpful whenever you're looking at your code visually without the help of IntelliSense to understand what this is. So if I were to just call this purchasable and this purchasable, I could still hover my mouse cursor over and see the word interface pop up. But people still, some people have some very strong feelings about this one way or the other. And I just say, whenever in Rome, do as the Romans. Whatever the other people on your team wind up doing, you just do that. But most of the examples you'll see online are going to use the I. Now, the able part at the end, it indicates that this is something that can be done. It's an action that can be performed. So I could call it iPurchase, but really these items are purchasable. They're buyable. Okay? So this denotes the true purpose for interfaces, which is to kind of specify an action that different classes can take, even though those classes are fundamentally different. Okay, and this will come into play a little bit more as we talk about the fundamental difference between an abstract base class and an interface. And we'll talk more about it at length, but this should give you some clues as to how to think about interfaces and how they're different. Interfaces are super, super, super important in object-oriented programming, not the least of which in when you're working in ASP.NET MVC Core, because dependency injection is a core piece of ASP.NET MVC Core, and it relies heavily on interfaces for that dependency injection mechanism. Perhaps none of that makes sense. I'll explain it to you in one of the last videos. I'll show you an example of the DevU project, which is running ASP.NET MVC Core 2.0 as I record this, and I'll show you how the dependency injection works through the agency of an interface. All right. So stay tuned. You'll get a fuller picture here as we go through it. All right. All right. So let's build on this in the next video. We'll talk about how to inherit from multiple interfaces and also from an abstract base class all at the same time. That's crazy. We'll see you there. Thanks.